Hi guys, this is the topic 6 video, graphing inequalities. So our first step in graphing inequalities would be to graph the related linear equation. So if it was an equal sign instead of an inequality sign, what would we do? We would plot the y-intercept, apply the slope, or make an intercept table if it's in standard form. Now before we connect them with a line, we first then need to decide what type of line. So these are where those bullet points come into play. If the inequality is a less than or greater than, we would graph with a dashed line. So that looks like this. If the inequality is less than or equal to or greater than or equal to, we graph with a solid line. So that's our regular line. Our second step is to pick a point that's not on the line we graphed and test it for true or false. So I always say use 0, 0 unless that's on your line. And our next step would be to shade the solution area. So back to step 2, if we test the point and it makes a true statement, then we would shade the side that that point is on. So if we test 0, 0, we would shade the side of the line that 0, 0 is on. If we plug it in and test the point and we get something that's false, we shade the opposite side or the other side of that line. So if we test 0, 0, the side 0, 0 is not on of the line. So let's do our first example. So step 1, graph. So if this was an equal sign, what would we do? We would start at -1, apply a slope of 3. Then, if we look at the inequality symbol, based on the previous slide, this means we would need to connect it with a dashed line. So in order for my line to be straight, it's going to look more dotted than dashed, but you guys get the point. Now, we move on to step 2. So we need to test a point. So once again, 0, 0 is not on that line. It's just to the left of it. So we are going to plug in 0 for x and 0 for y into the inequality and see if it's true or false. So if our inequality is y is less than 3x minus 1, we're going to plug in 0 for y and 0 for x. Let's simplify each side, and we get 0's less than -1. Now that is a false statement. So based on the slide above, we would need to shade the other side. So what I like to do is I'd like to put a little X over it and say, hey, don't shade this side, shade the other side. And that's it. So it's just like graphing a line, but we have shading and you have to choose dotted versus solid. Let's do a few more. So if the inequality is in slope-intercept form, like our previous example, we're going to start with that y-intercept. Plot it. Apply the slope, rise 1, run 2. Then we choose dashed or solid based on our inequality symbol. So this one is dashed. Now for testing the point. 0, 0. Again, it's a great point to choose because plugging in zeros for x and y makes our life a little bit easier, especially when there's fractions involved. So that means we need to plug in 0 for x and 0 for y into our original inequality. We get 0 is greater than -4. This time we have a true statement. So when it's true, that means 0, 0 is a solution, so we're going to shade that side. Our next one, y-intercept of -5 and a slope of 1. Then, our first time on these notes, we have a less than or equal to sign, so we will connect them with a solid line. Pick 0, 0 and test it. If we plug it into the original inequality, we get 0 is less than or equal to 0 minus 5. Simplify that, and we get a false statement. So just like the very first example we did, say, hey, 0, 0, not a solution, shade the other side. So when we look at inequalities, this really means that any point we pick in the shaded area is going to make a true statement, and any point in the non-shaded area will make false statements. So inequalities always have infinitely many solutions because there's always infinitely many ordered pairs you can pick in the shaded area. Pretty cool, right? All right, our next is graphing inequalities in standard form. So our steps are going to stay the same, except when we have equations in standard form, we use an intercept table to graph them. Again, going back to, I think it's topic 3 in our packet. So if we plug in 0 for x, we get a y value of 6. If we plug in a 0 for y, we get x value of 6. Plot those 2 points. Now, because of that inequality sign, we're going to use a dashed line to connect them. Our testing is staying the same. So try 0, 0, plug in 0 for x and 0 for y. and we get a false statement. 0 is not greater than 6, so I'm going to put a little X over it and shade the other side. The nice thing about standard form is if we test 0, 0, the whole left side will always just turn into 0. So it's almost less work than when it's in slope-intercept form. Let's do another one. So let's use our intercept table when we have standard form. If I plug in 0 for x, I get a y value of -8. If I plug in 0 for y, I do have to solve a little bit, divide both sides by 4, I get an x value of -2. Let's plot both of those points. So I do realize 0, -8 is going to go off the grid, just 1 unit, that's okay, but -2, 0 is fine. Because of the inequality symbol, we're going to connect them with a solid line. If I test 0, 0, again, based on what I said just a few seconds ago, the whole left side will go to 0, but if you like to plug it in and show that, go for it. So plug in 0 for x, 0 for y, we get 0 is less than or equal to -8, another false statement. So I don't shade that side, put a little X over it, I'm going to shade the other side. All right, we have 2 more examples and then the U-tries. So vertical and horizontal inequalities, again, all of these we're still just graphing the line as we would if it was an equal sign. So x equals -2 is a vertical line. So that means we'll plot a bunch of points with x values of -2. We have a less than or equal to sign, so we want a solid line to connect these. Now, if I test 0, 0, I'm plugging in 0 for x and 0 for y, but there's only an x, so we only plug in 0 for x and see what we get. 0 is less than or equal to -2 is a false statement, so we shade the other side. Y equals 4 is going to be a horizontal line. So we'll plot a bunch of points with a y value of +4, and this time we'll need to connect them with a dashed line because of the inequality symbol. If I plug in 0, 0, 0 for x and 0 for y, we only have room to plug in a y value. That's okay. We can plug in 0 for y and we get a false statement. So that means 0, 0 is not a solution. We can't shade there. We have to shade the other side. All right, the last thing you guys need to do for these notes is try these 3 U-tries on your own. Thanks for listening.